Welcome, everyone. My name is Dale Eisler, and I'm going to be the moderator today moderator or referee, as I said to somebody, for today's discussion on how does Saskatchewan get to net zero? What are the steps that we need to contemplate in terms of a net zero economy, carbon economy by 2050, which is the federal government's objective for our country. There are targets for 2030 in terms of our Paris Agreement goals, and beyond that, we go to net zero hopefully by 2050. So this is the first in a series of discussions about a net zero future. There will be three others, one on power production, one on mining, and one on agriculture, all on the same theme of a net zero future for Saskatchewan. And today we're very fortunate to have three people who know, I think it's fair to say, know the energy industry intimately, have deep experience in terms of the economics of energy, the challenges that the industry faces, and what it's going to take going forward in terms of mapping out a pathway to a net zero future. In fact, you know, we need to think of it in the context of the Saskatchewan economy, that we maintain a strong economy as we move to decarbonize the Saskatchewan economy. And of course, the resource sector and oil and gas are a big part of the economy of this province, so it presents all kinds of public policy challenges that we hope we can explore and you know, create a good public discussion about what is the way forward in terms of the future that we all want as we address the urgent issues of climate change. So I'll introduce our guests for today, and I'll turn it over to them in a moment. I think each of you have a PowerPoint presentation or a few slides. I know, Jim, do you? No, I can't. Okay, that's fine. So first is Corwin Bruce. On my immediate right, Corwin is Vice President of Technical Services at the International Carbon Capture and Storage Knowledge Center here in Regina. He has a mechanical engineering degree from the University of Saskatchewan, is a registered professional engineer, and has been working on the Boundary Dam 3 carbon capture and storage project since early 2009. He was the lead author of the Shand carbon capture and storage feasibility study, which details proposed second-generation carbon capture and storage facility on the Shand Power Station. So welcome, Corwin. Next to Corwin is Dan Mclane, who's the CEO and president of the Petroleum Technology Research Center. Dan became president of and CEO of PTRC in May 2017. He brings a huge amount of experience in the oil and gas industry. He was CEO and president of Tundra Oil and Gas from 2008 to 2014, and he spent many years, I think about 26 years, with Chevron Canada. His background is as a reservoir engineering expert, which has taken him to West Africa, the Middle East, Australia, United States, and Canada. So Dan really knows the subject that we're going to be talking about very well. He's a graduate of the University of Western Ontario in chemistry and chemical engineering. And finally, our third presenter is Jim Baker. He's the president of JP Baker Management Incorporated here in Regina. And Jim's got an extensive background as well in the energy sector, more than 30 years in the oil and gas industry, as a senior officer of 3 different oil and natural gas companies, and more recently as the director of several public companies, including Saskenergy, I believe. Is that correct? It's Saskenergy, which is a Crown corporation. That's exactly right. So Jim obviously knows the public policy side of these things very well. He's also been on numerous industry boards and sits on the board, or as we mentioned, the board of Saskenergy. So I'd like to welcome all 3 of you here today. And what we're going to do is they'll each speak for 8-10 minutes from their particular perspective on a net zero future. And then we'll engage in a bit of a discussion amongst them and with you. We'll open it up to questions here in Regina and also to the people gathered in Saskatoon. So hopefully we can have a kind of a discursive conversation here and get at some of the issues and the challenges and get our head around all the factors and issues that we have to contemplate for Saskatchewan as we move towards hopefully a net zero carbon economy by 2050. So Corwin, maybe I'll turn it over to you first to begin.
Okay. So the mic?
Yeah, turn it on. Come on.
Okay, can you all hear me? Can you hear me in Saskatoon?
Yeah. Yep. Yes.
Okay, very good. Okay, so thanks for the introduction. And thank you for having me here today. It's good to see so many people interested in charting out the path towards zero. So that's good. What I'm going to talk about today is CCS in general. I will, of course, reference back to some of the stuff we have within Saskatchewan because, of course, we've applied it to coal-fired power plants. But I think we're looking at it more generally in terms of CCS's role in a net zero future. And so that's basically the angle that I'm presenting this with. So just to get started here, so I'm with the International CCS Knowledge Center, which is here in Regina. That's a not-for-profit partnership between BHP, as in the Australian mining company, BHP Billiton, and SaskPower. So in essence, SaskPower provides people with background in carbon capture and storage based on the work that was done at Boundary Dam and other stuff that SaskPower has done. And we are fully funded by BHP to help to disseminate the knowledge that was learned as part of doing that project throughout the world. And so that is the mandate of the International CCS Knowledge Center, is to accelerate the deployment of CCS as a means of mitigating GHG emissions in terms of reducing the impact on climate change. So that's who I am and that's where I'm from. And I'm just going to give you a little bit of an introduction. Most of you have probably heard of Boundary Dam 3 before. So Boundary Dam 3, of course, is the carbon capture facility that is in Estevan, Saskatchewan. It's been running since 2014. During that time, it has captured in the range of 3 million tons of CO2, and it has taken that CO2, compressed it to a supercritical state, and put it into permanent geological storage in the ground, very deep down. It is a full chain process. So basically, what we mean by that is it's a coal-fired power plant. It is a carbon capture facility, and then it also includes the pipelining equipment, as well as the ability to both store the CO2 directly into a deep saline aquifer, which I think Dan will talk about more later, as well as sell the CO2 for its use in enhanced oil recovery, and then as a result end up storing the CO2 that way as well. And so that's basically Boundary Dam 3 and you know what the project all entails. After doing that particular project, we thought, well, we should take the lessons learned from doing Boundary Dam 3. So of course, it's the first one in the world, first coal-fired power plant in the world to be retrofitted with CCS technology. And so we thought the best thing to do was to take all the things that we thought of and kind of tripped over as we were building that project and bringing it along, and sort of distill them into what we thought would be the next generation of CCS facility. And so we did that as part of the Shan CCS feasibility study, which is a study that we did in concert with SaskPower and a couple of different arms of Mitsubishi Heavy Industries. The results of this study are a public report that's actually available on our website that you can take a look at, as well as a confidential report that was produced for the people who actually paid for the study to be completed. And in essence, you know, what we find from the Shan feasibility study is that you know, when you build a plant, a carbon capture and storage plant, the next time you learn from your mistakes in the first one. When you build it bigger, you end up doing it cheaper and reducing the cost of the overall facility. And so we think those are some pretty good findings from this Shan CCS feasibility study. You can see here that we project the capital cost of the facility to be 67% less on a per ton of CO2 basis. So of course, the facility is twice the size of Boundary Dam 3. And so that helps significantly, like it does in everything to do with the utility industry. Building bigger obviously drives significant cost savings. As well, we show that we have a cost of capture of about $45 US per ton of CO2 with this particular implementation. So getting into the realm of affordability versus, you know, where the current price of carbon is sort of being set and talked about within the world. A few other things that are interesting about it. The Boundary Dam 3 facility was made to be base loaded and only run at one particular load. And of course, when we projected out and looked about a future where there'll be more and more of these plants, especially when there's a grid that has more and more renewable resources that are in it, including wind and solar, which although zero emissions are undispatchable, we decided that we would make this new design so that it would be able to follow load. And so basically what that means is the coal-fired power plant and the CCS facility are designed in this particular second gen study so that it can back down to allow wind to generate and provide its energy onto the grid, or solar, or whatever. Interestingly, when we do that almost for free, when we dial back the power plant, the capture plant is actually now effectively oversized, and we're able to actually capture more of the CO2. And so what's really interesting about that is the current way of doing it. If you put up a wind turbine in North America right now, generally the backup of that electricity is coming from natural gas, and generally natural gas combined cycle. And so what happens is when the wind is blowing, or when you have a high amount of renewables, the natural gas combined cycle unit will drop back in load in order to let that generation come onto the grid. Now, when it does that, the natural gas combined cycle plant gets less efficient. And so actually it increases its unit emission intensity. Conversely with that, if you use a facility with CCS, whether it's on coal or whether it's on natural gas, it has the opposite impact. So when it backs up, it actually increases its capture intensity and actually magnifies and amplifies the impact of the variable renewable resources on reducing emissions. And so we think that's pretty cool. This just shows you sort of a graph of your different options of getting power within the world. And so you can see over on the far left side of the graphic, you have a traditional unabated coal plant, not dissimilar from what we would have in Alberta and Saskatchewan, that has an emission intensity of about 1,100 tons per gigawatt hour. You can see that there are newer ones that are more efficient that get down, into the 900 or 850 tons per gigawatt hour. You show that traditional natural gas plants that are about 500. The newest natural gas plants are maybe in the 375 tons per gigawatt hour range. You can see that we actually show wind energy. So because wind energy is not a consistent supply, obviously it has to be paired with some sort of backup, like we just talked about. And so it too has an emission footprint in the range of, I think we show about 200 or 250 tons per gigawatt hour. So that's sort of the range of dispatchable firm generation that you see there. And of course, you can see CCS on abated coal, like it would have been done at Boundary Dam 3, has the capacity, when it's running at full load, to get down to 120 or 140 tons per gigawatt hour. And so what this translates into is Boundary Dam 3, right here in Saskatchewan, is the cleanest fossil fuel power plant in the world, bar none, by a couple of orders. And so that's really impressive, I think, for us to have here in Saskatchewan. You can see as you continue on to the right, you do the second generation CCS, where you can actually go from 90% capture to maybe 95% capture, or include renewables to get up to 97% capture. And so obviously you get down to very low emission intensities. Of course, as we continue off the right-hand side, you can couple these generation options with bioenergy, and as a result, you can actually make negative emissions. And so, the IPCC report is calling for significant amounts of negative emissions, and that's actually relatively easily achievable with coal-fired power plants that are made to burn solid fuel that have already been retrofitted with CCS. So in essence, you can drop in a bioenergy or a biofuel, such as wood pellets or straw or coppice crops, and get significant negative emissions. So in essence, literally pulling CO2 out of the air effectively. The other thing interesting about this, just before I leave this, is that you can see on the very right-hand side the Canadian regulations on coal-fired power plants. So they currently have an emission standard of 420 tons per gigawatt hour. And so what that means is here in Canada, any coal-fired power plant that doesn't emit less than 420 tons per gigawatt hour will be required to shut off effectively by 2030. And there's no other technology, honestly, that can get them down to less than 420 tons per gigawatt hour. So in essence, that law mandates CCS be implemented on coal-fired power plants, or they must be shut down. And so that's enough about coal-fired power plants and that sort of stuff. So obviously, there's other emissions in the world, not just the power sector. You can see that this is the overall emissions by sector throughout the world, as per the International Energy Agency. And you can see that power, which we've been talking about, represents about 39% of the overall emissions throughout the world. Currently, we're at 2.4 million tons of CO2 capture capacity. So that basically is Boundary Dam 3 at the capacity of 1 million tons, and a plant in just outside of Houston, Texas, which has the capacity of 1.4 million tons. So those are the two facilities in the world that make up the amount of CCS we have in the power sector. You can see that as part of the sustainable development scenario that the IEA has produced, they project that we're going to need 1.5 gigatons, so that's 1,500 million tons of CO2 capture per year by 2040. So it's a huge difference in number, and we're just talking about the sustainable development scenario. We're not talking about net zero. That would be even further. Also, if you look to the other side, of course, we understand transport, and that's something I won't go into here today. There's also a pie there for industry. So industry would be the cement industry, the steel industry, these sorts of emission-intensive activities. And so you can see there that in the sustainable development scenario, there's a requirement for 10 gigatons of CO2 capture from iron and steel, 5 gigatons from cement, and 14 gigatons from chemical facilities. So, according to the scenarios we have, there's going to be a huge build-out of carbon capture and storage if we're to get to the sustainable development scenario. Interestingly enough, over at the International CCS Knowledge Center, we just announced, I think it was in the fall, that we're actually doing a feasibility study for the Lehigh cement plant in Edmonton. And so we're looking at fitting it with a carbon capture system such that we can remove in the range of 700 to 800,000 tons of CO2 per year from its emission stream. Do we want to take questions, or should we just finish?
Well, I think we should just go through all three, and then we'll take questions.
Okay. And then the bottom point on this, of course, is that CCS, but with bioenergy, will be needed to deliver negative emissions. And this is sort of what it looks like. I mean, in essence, CO2, the sun uses CO2 in plants to fix it in plants. You can then take that and burn that in your energy facility, either in combination or in replacement of coal. And when you retrofit this with CCS, you in essence effectively, if you draw the circle around it correctly, you get CO2 and energy going in, and you get CO2 stored underground and CO2 going to the grid on the other side. And so that's effectively how bioenergy with CCS would work. It's interesting, of course, since we're in Saskatchewan, because in Saskatchewan we're sort of the Saudi Arabia of biomass. So we have got all sorts of biomass. We have somewhere north of 30 million tons of crop waste per year and residuals. We have a significant amount of capacity for wood pellets within the north. And then we have marginal land down in the southwest of Saskatchewan that appears to be amenable for use for growing energy crops such as coppice, poplar, and willow, and that sort of thing. So I think that's one of the other things that Saskatchewan can look at is our potential not only to feed our own energy needs, but actually to export this biomass around the world to help other people reduce their carbon footprint. And so I think that's kind of an important thing for us to think of here in Saskatchewan. And that is the end of my spiel, so I will pass it over to Dan Mclane.
You had to mention Saudi Arabia.
Oh, sorry. That was a bigger speech.
Yeah, it was a Sunday evening around 9 p.m. I happened to check my phone. I should never have done that. Things changed in a heartbeat. The industry was starting to bounce back a little bit, and then Saudi decided to exercise its option. And but I've been in this business for 40 years, and if there's one thing that you can depend upon is the cyclicity of the oil price. When I started in 1980, the price actually was around $30 a barrel. Within about a year and a half, it went down to 15, and it stayed there for something like 20 years before it started to come up. So I want to say it's normal. It's not normal, but it happens, and so we'll deal with it. Okay. All right. Well, thank you very much for having us here. I'm going to take a few minutes and talk a little bit about what PTRC is and what we do. And then I'm going to talk about something that maybe you probably wouldn't expect, and that is that to get to net zero, you need to produce a bunch more CO2. Okay? Sounds contradictory, but you'll see why. And then The thing I want to leave you with, if you take nothing from this, is that Saskatchewan, this little province of Saskatchewan, is a world leader in research in carbon capture, CO2, enhanced oil recovery, and storage. So I'm going to repeat that near the end. This slide here shows you the history of PTRC. We came together as a result of an initiative from the province of Saskatchewan, the federal government, Saskatchewan Research Council, and the University of Regina. And our goal at that time was to support research in oil and gas to improve recovery here in the province. We have evolved that now to also focus on reducing the environmental impact of our industry in any way, shape, or form. And as a consequence of that, we got into CO2 enhanced oil recovery. From 2000 to 2016, the PTRC was the quarterback of all the research, measurement, and monitoring going on in the world's largest CO2 enhanced oil recovery project in the world at its time. That's the Weyburn-Midale CO2 EOR project. From there, we went on to become the quarterback of all the research going on in Aquastore. You may have heard of that term. That is CO2 storage into a deep saline reservoir called the Deadwood, right on the property of Sask Power, and it's connected to the carbon capture facility there. We were also involved very heavily in the international standards for CO2 EOR and storage. Heavy oil is a large part of our province. Up in the Lloydminster area, we've been actively involved in research to assist big operators like Husky and CNRL in that area to improve their recovery. And over the last few years, we have been looking at using CO2 to assist that recovery, which, by the way, those reservoirs can actually store that stuff too. And we've also been doing some things in tight light. So that's us. We've been around for 22 years. We've spent over $200 million in research funds from the province, the federal government, and industry on measurement, monitoring, and verification. We've partnered with hundreds of companies and organizations to support this, published multiple papers, and 300. We've, as a consequence of our efforts, probably identified 300 million barrels of new reserves from that research. And doing the math, that's worth about $3 billion worth of royalties to the province. At Weyburn CO2, and I'll speak a little bit about this in the future slides, we've stored 38 million tons of CO2. With regards to heavy oil, as a result of our research, we have the first CO2 EOR project in heavy oil. And as I said, we are a world leader in this area in research. This slide just shows you a lot of the partnerships that we have had or have actively going on with universities, with organizations, companies, and with regulators. We have a couple new ones hopefully coming on board here from Europe in the very near future. We are part of a very interesting alliance of organizations here in Saskatchewan. The Knowledge Center is here. I mentioned the Saskatchewan Research Council, the University of Regina, and the University of Saskatchewan. We are all involved in research around a lower carbon economy, reducing the impact of a vital industry to our economy. And so that's an important takeaway, that this small province has all these organizations all working on these common themes and goals. I'm going to talk about Aquastore. It's been around now for about 5 years. We store CO2 from Boundary Dam's carbon capture facility into a deep saline reservoir. This deep geologic reservoir is 3,300 meters down in the ground. Our job is to ensure the public that it will stay there forever. And we do that by means of a whole host of measurement and monitoring activities, including a thing called seismic, where we can actually monitor the plume, the CO2 plume, as it moves through the reservoir. Quite fascinating. The takeaway point here is that of the 280,000 tons of CO2 that we've stored there so far, That's equivalent to taking 70,000 cars off the road in 1 year. It gets more interesting than that when we start looking at Weyburn. That's been injecting for quite some time. They've injected 39,000 million tons of CO2. And this is an important point. We put CO2 into oil reservoirs, and yes, we do produce some more oil. But that barrel of oil that we produce from a EOR reservoir actually has a lower carbon load than if you produce that from a conventional reservoir. You are storing CO2. It will stay there forever. And then, again, that's what we do. We monitor it, and verify that it will stay there forever. And you can see that some of the CO2 does return. It does cycle, but it gets reinjected back into the reservoir. It's a closed system. No CO2 goes back into the atmosphere. And as a consequence of injecting that CO2, the economy has benefited from it. We've produced an additional 130 million barrels just from this at an estimated cost based on $50 a barrel US. Maybe not today. But in the past, $6.5 billion of value, of which at a 10% royalty, that's $650 million to the province. Okay, so here's the deal, and this is what we are advocating, is that we would like to see more CO2 enhanced oil recovery projects in Saskatchewan. We have one, Weyburn. We have 500 to 600 reservoirs in southeast Saskatchewan alone. A lot of them could lend themselves to CO2 enhanced oil recovery, and if we could do that, there is potentially 2 billion barrels of incremental reserves available from CO2 EOR. And based upon certain rules of thumb, that is equivalent to injecting 660 million tons of CO2 into the ground, storing it there. You can call it storage into depleted oil reservoirs if you want. The consequence is you produce a bit of oil. Okay? That's how you pay for it. That's equivalent of taking 166 million cars off the road. There's 36 million people in Canada. That's 3 cars for every person. So it has a huge, significant impact. And so that's where we would like to see a lot of research go towards supporting more enhanced oil recovery. We'd also like to see capital going into more carbon capture and building networks to deliver that CO2. And other places where you can capture that CO2, not just from Boundary Dam or Shan, but we have fertilizer plants that produce CO2. We have federated co-op. We have potash facilities. If we could connect all that CO2 and use that in depleted oil reservoirs, it'd have a significant impact. Okay, so the estimated value, $100 billion, $10 billion to the province. And I just want to leave you with this statement, that Saskatchewan is a world leader, leading center of excellence in low carbon energy research. We lead the world in commercial carbon capture, utilization, and storage for the purposes of lowering CO2 emissions today. And the world is coming here. You wouldn't believe how many people we entertain from around the world coming to see Aquastore, coming to see the carbon capture facility. The world has finally woken up. If you want to get to anywhere near the Paris Accord, you need carbon capture and storage. Thank you.
Jim?
Good afternoon. First of all, I want to start by saying that I'm an oil and gas guy. Showery with what you like to. Having said that, I've also been very keen on the environment. And by that, I say this. Founding partner of Urban Forest Recyclers in Swift Current. We cleaned up all the blue boxes in Western Canada and make egg flats and fruit separators. We started that business. I was one of the first guys regarding flare gas capture. I worked with the government on legislation. I tried very hard. We started a power company to take flare gas and turn it into power. Unfortunately, our crown in Saskatchewan isn't that amicable to third-party generation. I'll be very honest with you. And we've since moved that company to Calgary. I've been involved in 9 oil and gas companies that we've started. 7 of them southeast Saskatchewan. We drilled all our wells in southeast Saskatchewan, produce. And we also have a capital company, and the capital company raised funds, and we funded private junior oil and gas companies based in southeast Saskatchewan. I can honestly say that our group has been involved in not only the production of oil and gas, but I believe in the technologies these gentlemen are talking about. Everything from CO2 capture to the likes of what the PTRC do. I was one of the 3 people involved with, and I'll give Ralph Goodale credit for this, in the starting of the PTRC. So I'm gonna take you back 10,000 years ago. I'm a geologist, right? So 10,000 years ago, what did we have in Saskatchewan? Right where you sit today, 2,200 feet of ice, all right? There was glaciers. It was a different time in Saskatchewan. Let's fast forward to today and look at our Arctic. All the jibber jabber about CO2 and the environment and glaciers melting, there's never, I like things to be put in context so that if you look at what's happened in the world, the planet over the eons has ebbed and flowed on ice age, warm spells. Back in the Cretaceous, 90 million years ago, we had dinosaurs running around here. Scotty was probably visiting Regina at this time, right? So the world has changed. The glaciers are gone now. We've gone through a very warm spell on the planet. And now we've got the Antarctic, which is actually still growing, and the Arctic is melting, right? Have we made a difference with 7 billion people on the planet? I would say yes. And part of that reason is because we use petroleum and coal and all the rest of it, right? So what I'd like people to think is to put the whole debate on oil and gas. Our industry has been absolutely gutted over the last 5 years because of regulation in Canada. We produce the greenest oil on the planet, bar none. I've been around the world in oil and gas companies. We produce the greenest oil on the planet. We have the most regulation. We do most carbon capture, flare gas capture, all those sorts of things. And yet we're being vilified and as the bad guys in this whole equation. And we are a very, very small fraction of the problem in the world today. Canada is a very small part of that. And top of that, we do a bunch of research like you saw today. So when we think and when we talk about the whole issue around oil and gas, CO2 emissions, do we ever talk about Canada as a carbon sink? Vast forests relative to our population. Nobody ever talks about the carbon sink that we have in this country. Because we do. We have it. We are part of that, right? So when we're talking about the oil and gas industry, let's talk about all of it. Let's put it in context, right? We know we have to do better, and we have. The oil sands in northwest Alberta have dropped their emissions by 40%, and they continue to drop them. They've done a very, very good job. Is it perfect? Absolutely not. Look around the world. One only has to go to China. I've been there a number of times. One has to go to India, Russia, Southeast Asia. China today, we produce 1,500 megawatts of coal in Saskatchewan, power. China produces 1 million megawatts of coal-fired power. They just commissioned 40 brand new coal mines. They're commissioning 300 to 500 brand new coal-fired power plants. And we're the problem? And we're spending the money that we do on the research on that? I beg to differ. I think that we're the ones that should be looking to them for that research and technology and applying it here. You know, I guess the point I'm making is let's be sure we know all the facts. We have to do a better job. Everything that happens today, how you got here today, the clothes you wear, the buildings you're in, all took energy. Your cell phone, energy, plastics, oil and gas, it all takes energy. So you're not going to cure that problem in 3 to 5 years. You're going to cure it in 30 to 50 years, maybe, right? Again, we put that into context, right? So I guess what I'm saying today is that the Chinas, the Indias, the US, the USSR, Southeast Asia, they are the big problems in the world today. Canada's not. the fact we can't get pipelines built, the fact that we can't do an energy project in this country, which provides the tax revenue for education, for social services, healthcare, right? Again, put it into context. So I appreciate what these people are saying about what they're doing in the research, and I'm all for it. I believe we need to do more of that. Having said that, let's make sure that we as the voice, you know, you're the educators, you're the students, you're the, you know, the people that communicate with the population. Let's make sure the whole story is told, right? Because in the last 5 years, our industry, a loss of 200,000 jobs in Alberta, in Saskatchewan, in the oil and gas industry, and the indirect jobs, you know, you can say, okay, those are just jobs or whatever, but, you know, we can't get anything built in Western Canada. Bill C-69 and the list goes on. Quebec last year, they got the green light in record time to build a cement plant that's got half the emissions of the Tech mine in Alberta that was just canceled. I don't know what to say. I do know what to say. I'll just leave it at that. So I'm just, again, I'm trying to give you some perspective on the whole thing, all right? I'm happy to go through questions and answers relative to what we talk about today. I'll leave my comments on that. I've been a producer. I think we've done a good job in what we do in Saskatchewan and in Canada, period, because of regulation. And remember that the world should be wanting our oil versus anybody else's oil. Go to Saudi Arabia. God, they burn hundreds of millions of cubic feet of gas a day just to desalinate their water, let alone produce all the oil they do, right? So put it in perspective. Thank you. Okay,
thanks, Jim. All right, well, we'll get into a back and forth here. I have a couple of questions, maybe just get started. Jim, your comment that we produce the greenest oil on the planet, I don't know if I entirely agree with that. I think we've certainly made improvements over the last 20 years, but I don't think it's the greenest oil. If there's evidence that you can present to correct me, but my understanding, at least a few years ago, we certainly didn't. The other thing is, oil sands emissions have dropped by 40%. 40% in terms of intensity, perhaps, but not in aggregate number. Well, the oil sands emissions have gone up considerably. So they've made progress on emissions, that's true, but certainly not in total amount. So those are just kind of two little points I make, right? Your point about we're a small part of the global issue, no doubt about it. We're what, 1.6% of total global emissions. So if you eliminated all our emissions in Canada, it would almost have no measurable effect globally, right? So I mean, we do have to keep that in mind in terms of how big an impact we can have, even if we get to 2050, right? Given what's happening in other parts of the world. The IEA is predicting that India will surpass China in 10 to 15 years in terms of emissions. They're going to increase fivefold from where they are currently because of the economic development and the growing middle class in India. So just, you know, so I'm saying, to your point, keep in context how we're a bit player in all this, which is very true. Now the other thing I would say, I guess, just listening to what each of you said, I draw from that you all are supporters of a carbon price. That you need, if we're going to get to net zero, we need to have a realistic carbon price. Corinne, you mentioned that for carbon capture, you're in the range of $45 US, the cost of per ton of capture. So I take from that then, if we are actually going to incent carbon capture in the future, we're going to have a pretty strong carbon price to actually make financial sense for large emitters to actually deploy it.
Right. So just to jump in there, I mean, so we're involved with CCS projects around the world, and there's different models that incentivize them. And what I would say is that no one will do a carbon capture plant for free. Now, there are other jurisdictions that will use an incentive like we have in the U.S. So rather than a carbon tax, in the U.S. they actually have what is effectively a bounty on carbon, such that if you take CO2 and you store it underground through a tax provision called 45Q, you can get $50 US in reduction on your taxes. In Norway, for example, they are funding the entire cost of the plant potentially. So when I talk about $45, I wouldn't say necessarily that's a tax. I would say there has to be a revenue stream that's associated with it to offset it, which is like any other.
Well,
business.
a price, right? I mean,
There has to be a value on carbon.
You have to put a value on carbon,
Yep.
a price on carbon, exactly. So, do you guys support a price on carbon? Do you think it's a good instrument if we're serious about reducing emissions? Should there be a price on carbon?
So just to back up, so if we look at what they're doing in the United States, not to put a point on it. So if you look at it and you put a cost on the carbon based on the stuff that you're burning, you're going to miss a whole bunch of easily mitigated biogenic sources. So in the U.S. at $45 or $50 U.S. per ton through 45Q, ethanol plants, which currently pay no carbon taxes because it's biogenic CO2, are actually starting to retrofit with carbon capture technology in the U.S. And so because of the instrument we've chosen, if you chose a tax on the fuel you burn, they're not burning fuel. They're getting biogenic CO2, which doesn't count. So it doesn't quite draw as much of a swath as if you just put a bounty on CO2 itself.
Okay, but just on a carbon price. I mean, we talk about, we want to reduce our emissions, and carbon capture is a part of that, and what Dan talked about, enhanced oil recovery and how we capture carbon around that whole issue. But would a carbon price make it more feasible economically for the sector, whether it's oil and gas industrial sector, to actually go down that road? Like, that's what I'm asking.
Okay, I'm going to take off my PTRC hat to answer this question. First of all, in its current form, the carbon tax is nothing more than a consumer tax. It serves no purpose other than to create revenue for governments, and then you have to reimburse the individuals. It's idiotic in its current form. I do like the idea of carbon credits. I like the idea of the industry working to reduce emissions, and if it requires some kind of system or program that enables credits to be used nationally and internationally, then great. I think that it's almost like a currency in and of itself. I think that would be more effective, but this thing has to be thought out a little more than in its current form. Not to sound too trite, but to be able to stand up in front of the world with your hand over your heart and say, we put a price on carbon, aren't we great? That doesn't do anything.
And I agree. Because it has to be a level playing field. Look at the U.S., right? Look at our neighbor, who are our biggest trading partner, right? So it's got to be a level playing field. So you're going to decimate the industry in Canada and the jobs and the revenue and everything else over that, There's other ways to be doing this, I think. Let me just use a quick example. Mining a bunch of coal in BC, bunch of energy to do that. It gets on a train, it uses energy to get to the West Coast, gets to Roberts Bank, gets on a ship, and it goes to China. It gets offloaded to China and goes to some big factory and they make windmills, right? Biggest windmills in the world are made where? In China. And what do? They turn around and put them back on some form of transportation energy, get them back to the coast. They put them on a ship and they ship them back to Canada, then use a bunch of energy to get that same windmill to wherever they're going to erect it, and they put it up in the air, and all of a sudden we have green power. Does anybody see the issue there? Right? So again, put things in perspective. Yeah,
okay. We'll turn it over here to the audience very quickly, but I'd like us to get to the subject of, I personally feel that we've never had an honest debate in this country on climate change and energy or whatever, on both sides of the issue. I think nobody is being really truthful and frank, because fundamentally, for us to achieve our goals, our climate goals, I believe we're talking about a lower standard of living for people. There is no painless transition here. There is no way you move off a fossil fuel economy quickly, which has been the cornerstone of our standard of living and quality of life, and move down the energy density scale from high density fossil fuel to low density solar and wind, without it taking or having a real big impact on standard of living. And of course, nobody wants to talk about that, right? So I hope we can get into a little bit of that, about what does this actually truly mean for our economy and society, because you will get the people who talk, advocates for addressing climate change very aggressively, as if this can be somehow painless. The whole idea of a carbon price is to change people's behavior so that they don't use as much energy They don't drive their cars. They don't have 2 or 3 cars. They don't have 3 television sets or air-conditioned homes or whatever. That's part of the answer, which means an impact on standard of living. And I think that's something that we never discuss. And the other thing is, in terms of realism, do we honestly believe that we're going to get 194, 95 nations around the world to coordinate their economic, environmental, and fiscal policy on this subject? We can't agree in Saskatchewan, let alone Canada. And we think the world is going to do this? Like, it puzzles me how we actually think this is going, it's unimaginable, this problem, in terms of how do you deal with it as a public policy issue on a global scale. Because here we are in Canada with such a small amount of the GHGs, 1.6%, and we can't agree. And we think the world will, when you have emerging countries that need energy, right, to raise their standards of living. Like, I mean, somehow I think this has to get injected into the conversation. So that's my soapbox. I want to thank the folks in Saskatoon. I hope you could hear this reasonably well, and thank you for your input and questions, and to everybody else in the room. And I mean, critically important issue and discussion that is going to carry on for many years, and hopefully we'll achieve our climate change goals. So thank you very much.